Okay, so 16.2 is basically some information about titration and some vocabulary that goes with it. And then the second video will be on actual titration calculations. So the first question is, what is titration? So titration is basically the controlled addition of one substance to another substance, in which you actually know the concentration of one substance and you don't know the concentration of another substance. And the goal is to figure out how much of the known substance is needed to completely react with the unknown substance. Or I should say the unknown concentration substance. One is an acid, one's going to be a base. This is also an experimental way to find pH, but we won't get into that specific calculation. So indicators are important to titration. You have to add an indicator in order to see results. So an indicator is basically a compound whose color will change in response to a pH change. You must make sure that you choose an indicator that's going to actually work for the pH you're expecting. So for example, the indicator we use in lab, a common indicator, and also the indicator in this picture up here is called phenolphthalein. Phenolphthalein is a clear substance, and it's clear until pH of 7 is reached. After pH of 7 is reached, it turns pink. So in this picture, you can see it's clear, there's a little bit of color starting to appear, and then you have this very light color change. That is when that pH change occurred. The more you add of the one substance to the other, the greater the change in pH that will happen. So when you're titrating, you're looking for the color indicator to be the lightest color possible and actually stick and be permanent. So here's just a list of some indicators and their color at the low pH versus the high pH, and also the specific range at which they work at. So once again, you want to know what your pH range is going to be in order to pick the appropriate indicator. If you don't know the pH range, then it's a guessing game. So you would pick something low, see if that works, middle, and then go from there. So once again, just an example of using two different indicators here. So phenolphthalein, like I said, is clear up until about pH 7, and then it will turn very light pink and increase in pink. The other one is from 0 to 6, yellow. So this will work at a lower pH. From 6 to 8, it's green, and then from 8 to 14, it's blue. Specifically down here, the color change. So in this case, phenolphthalein, you would not want to use for something where the pH change is going to occur below 7. Instead, you could use the other indicator. I don't know why this is here, but that's okay. I do know why it's there. There we go. So litmus paper basically is just a little strip, either blue or red. It's like thick tissue paper. And this can tell you if something is acidic or basic. That's it. Doesn't tell you the specific pH, but it can make you determine if it's an acid, pH of about 0 to 7, or if it's a base, a pH greater than 7. So there's two options you have with litmus paper. You can use red litmus paper, or you can use blue litmus paper. It doesn't matter which one, they tell you the same thing. So if you dip red litmus paper into an acid, there is no change. It's still red, it's just wet. If you dip red litmus paper into a base, it goes from red and changes to the color blue. Vice versa, if you use blue litmus paper and you dip it into a base, no change occurs. If you dip blue litmus paper into an acid, it goes from blue to red. So a little trick on remembering specifically blue acid or blue litmus paper is blue to red, I said. Or you're really supposed to say blue to red acid, like acid. So blue litmus paper changing to red means you have an atmos. An acid. Blue litmus paper changing to red means you have an acid. Red litmus paper changing to blue, B for blue, B for base, means you have a base. So here's what this actually looks like. So red litmus paper with a drop of base turns blue. blue litmus paper with a drop of red acid turns red. So it doesn't matter which one you use, you figure out the same results. If you want to be extra sure, you can use both. You can get this really cheap on Amazon or things like that, hardware stores. And litmus paper is commonly used in sciences, not as commonly used in the natural world. Instead, we use pH paper. So pH paper, of course, is going to tell you acid or base because it's going to tell you the specific pH of a substance over a rainbow scale from 0 to 14 that we already stated. So pH paper is like this orangey color to start, and you dip it in a substance and it goes anywhere from red, which is a very low pH, acidic, orange, yellow, and then it starts turning greenish at the lower bases, and then the whole way up to a strong base with a strong pH, high pH to blue. So even if you have a farm, well water, pool water, you may have pH paper on hand because it's an easy way to test to see if your water is where you need it to be. Another indicator you can use, which is natural, is cabbage juice, specifically from a purple or red, depending on the terminology, cabbage. So basically, it's also a rainbow color scale, not the same rainbow color scale as pH paper though. That's important to remember. So for cabbage juice, it's from a red or purple cabbage. It starts out as like a purpley bluish color. And then if something's very acidic, it will turn pink, pinkish red, like down here. If it's neutralish, it'll turn kind of be bluish, purplish. And then if it's basic, it will turn greenish to yellow. So this is just a natural indicator. So say you really need to test the pH of something. You don't have any litmus paper or pH paper on hand. You could go to the grocery store, buy a red cabbage or purple cabbage, same thing, and make your own indicator. Super simple and very accurate, just not as accurate as legitimate pH paper. Also, just going back to pH real quick, you can actually buy specific pH. So this is a full range pH, 0 to 14, even though it says 10. You can actually buy like 1 to 4 and get an even more specific pH down to a decimal. But in general, you can just use the rainbow scale. So just showing you how this cabbage juice indicator works. You take your cabbage, it has to be a red cabbage, purple cabbage, chop it up, put it into some water, boil it for a couple of minutes. The cabbage releases some juice. You strain off that juice, and now you have it as an indicator. And like I said, you can add that to specific substances, a liquid added to a liquid, and it can tell you the pH by this color changing scale. So red, very acidic, yellow, very basic. So the last thing I want to talk about is the transition interval. So the transition interval, we kind of already touched upon this, is the specific pH range over which an indicator works and where it changes color. So once again, you want to know what kind of pH you're working with so you have this color change occur. So for example, methyl orange only works over pH 4 to 6. It's going to change from orangish to yellowish. So if you have something at a greater or lesser pH in this range, not going to work. So here's just some common indicators, and it shows you the color they start at, the color they end at, and the range at which they work at. So once again, we have our phenolphthalein down here, colorless, and then changes to pink over about a 6 to 8-ish scale. So once again, you want to know the general pH you're working with in order to pick an appropriate indicator. If you titrate and nothing happens ever, it's just that you have the wrong indicator and the wrong pH scale.